All right, guys, here are the notes for section 5.6b. The big thing in this section that we're going to learn is we're going to learn more about linear equations, especially the equation, and we're going to learn a better way to graph an equation, which I'll go over in a minute. First up, let me review a couple things. On a graph, one of the important things about a line is its slope, and we have learned two different ways to find the slope of a line. One way you should know is you should be able to find the slope between 2 points. You would do that by using the slope formula. For example, if I had the points 2, 7 and 5, 9, and I wanted to calculate the slope between those points, I could plug them into the slope formula by saying 9 minus 7, 5 minus 2. That would be a slope of 2/3, and I'm done. The slope formula. The other way that we learned how to calculate the slope of a line is by looking at a graph and using what we call the triangle method, where we calculate the rise over the run. All right? For instance, if we had the graph of a line, and we put some points on that line, so it looks like that. We can calculate the slope of that line by taking those 2 points and making a triangle, all right? And we are calculating the rise, which in this case would be 2, over the run, which in this case would be 3. So the line goes up 2 over 3, or it has a rise of 2 and a run of 3. Also giving you a slope of 2/3. That rise over run, being able to do this is going to help us graph lines so much quicker. The rise over the run. We're going to take that in a minute, and instead of using that to calculate the slope, we are going to use the slope to draw the line. We'll get to that in a minute. Last thing is, what does the graph of an equation represent? Remember, what does this line represent? It is the solutions to the equation. Every ordered pair that's on a line is a solution to the equation for that line. All right. We got one more review thing, and that is graphing lines. How have we graphed lines up until now? We have graphed lines by making a table. Making a table is a valuable skill to have. You will still graph lines, or at least equations, by making tables. Today we're going to see a better way to graph linear equations. So let's go ahead and graph this equation the old way. Let's make a table. And I get to pick any 3 x values I want. Say I like to pick 0, 2, and 4. And one at a time I would substitute those in for x. So I would get 0 plus 3y equals 9. 2 times 2 plus 3y equals 9. And 2 times 4 plus 3y equals 9. When x is 0, I get 3y equals 9, and if I divide both sides by 3, I get y equals 3. When I put 2 in place of the x, I get 4 plus 3y equals 9. And I would subtract 4 from both sides and get 3y equals 5. And I would divide by 3 and get y equals 5/3. You You might remember that 5/3 is it's exactly 1 2/3. And last up, when I put 4 in for x, what do I get for y? I get 8 plus 3y equals 9. I would subtract 8 from both sides and get 3y equals 1. I would divide both sides by 3 and get y equals 1/3. So I can then take those points and graph my line. The first ordered pair, 0, 3, would be 0 to the right and up 3. The next ordered pair would be 2 to the right and up 1 2/3 of a block. And the last ordered pair, 4, 1/3, would be 4 to the right and up just 1/3 of a block. You can see those line up in a straight line. I can go ahead and connect them. And there's my line for that equation. Okay, that's a lot of work. It's not terrible, but it requires showing a lot of work. Let's see a better way. So, a better way to graph a line is to use what is called slope-intercept form. It is where an equation looks like this, which most notably, the y is by itself. We spent a long time we spent all of last night's homework solving equations for a variable, and that is what you're going to need to do today. You're going to need to be able to take an equation, like say 2x plus 5y equals 10, and you're going to need to be able to solve that equation for y. You want to be able to get the y by itself. So it looks like this. Once the y is by itself in a linear equation, the equation is in what's called slope-intercept form. So let's see what it says here. When an equation has been solved for y, it is in slope-intercept form. The coefficient of x, all right, the coefficient of x, that is the m, will be the slope of the line. Isn't that cool? So when the y is by itself in an equation, whatever number is in front of the x, that will be the slope of the line. And the b value, this number out here, will be the y-intercept of the line. So what I'm saying is, just by taking an equation and getting the y by itself, you suddenly know what the slope of the line is and what the y-intercept of the line is. In this case, this would be the y-intercept. That's the number that's not attached to the x. And this would be the slope. That is the number that's the coefficient of x. And if you know the slope and the y-intercept of a line, then you can graph the line like that. Takes no time at all. All right, so here are skills you need to have when given an equation. Can you solve it for y? Thus putting it in slope-intercept form, right? That's why we practiced that last night, taking an equation with two variables in it, x and y, and solving it for y. And then once you have solved it for y, can you name the slope and the y-intercept? Do you recognize which number is which in the equation? All right, the slope is always going to be the number that is the coefficient of x, and the y-intercept is always going to be what we call the constant term, which is the number that is not attached to a variable. All right, once you have an equation, so once you've done this, and you have an equation in slope-intercept form, you can quickly graph the line. It just takes a couple steps. First step, Now that you know what the y-intercept is, plot the point on the y-axis where the y-intercept is. And then starting at that point, the y-intercept, you're going to use the slope to plot more points. Remember, the slope is simply the rise over the run. So the top number in the slope, when the slope is a fraction, the top number tells you how much to go up or down, and the bottom number tells you how much to go left or right. Let's do an example and see that. So we are going to graph the same equation we already did at the top, but this time we're going to do it by putting it into slope-intercept form. To put this in slope-intercept form, I would first subtract 2x from both sides. Now, some people, when they subtract the 2x, they like to do this. Okay, the 9 and the minus 2x are not like terms. You can't combine them, right? But you could put them in either order that you wanted. Some people would like you to put the x term first and the positive 9 second, so it looks like that. And the reason they want you to do that is because that's the way slope-intercept form looks, mx plus b. The x term comes first, and the number comes second. I don't particularly care. In fact, whichever way is more convenient is probably okay with me, as long as you can remember to focus on the fact that whatever number is in front of the x ends up your slope, and the other number is your y-intercept, and it doesn't really matter which order they come in. All right, finishing off this equation over here then, I would be dividing everything by 3, and I would end up with y equals 3 minus 2/3 x. That thing is now in slope-intercept form, and I can say that the number here is the y-intercept. And the number in front of the x, the coefficient of x, is the slope. So, I am ready to go ahead and graph that line. Look, once you know those two numbers, graphing it is a snap. You start by putting a point at the y-intercept. This line crosses the y-axis at 3. And the slope is how you graph more points. The top number being -2 is telling me I need to go down 2. The bottom number being a +3 is telling me this line goes 3 to the right. So I need to go down 2, right 3, and there's my next point. I can do that again if I want, except I run out of graph. Down 2, right 3. And a nice point to make here is you could switch both directions if you wanted. Instead of going down and to the right, you could switch and go up and to the left. Instead of down 2, right 3, I could go up 2, left 3. Same line. And that is the same line that we graphed back here at the beginning, right? All right, that is the main focus for today. Can you take an equation like this one? Can you change it into slope-intercept form and then use that to graph it quickly? Let's do a couple examples here. So first, let's practice taking an equation and changing it into slope-intercept form. So we're going to change it into slope-intercept form, and then it's asking me to name the slope and the y-intercept. So over here, nope, I don't want to do that first. Over here, let's put y-intercept and slope. Y-intercept and slope. All right, so this first equation, to get the y by itself, I would first subtract 5x from both sides. That's going to give me -3y equals 12 minus 5x. Now you got to be careful with the signs here. The next thing I'm doing is I'm dividing by -3. That gets me the y by itself. 12 divided by -3 is -4. And -5 divided by -3 is a positive 5/3 x. Right? 5 can't be divided by 3 evenly, but a negative divided by a negative is positive. So now that I'm in slope-intercept form, I can tell you that this number is the y-intercept, that's -4, and this number is the slope, that would be 5/3. To graph that, I would put a dot at -4 on the y-axis. I'd go up 5, right 3, up 5, right 3, and I'd have my line. The next one. To get the y by itself, the first thing I would do is subtract x from both sides. That's going to give me 4y equals 10 minus x. And then I'm going to divide everything by 4. And that gives me, well, 10 divided by 4, I'm going to make it a decimal. 10 divided by 4 is 2.5 minus. Now you want to remember there is a number in front of that x even though we don't write it. The number 1, that's like 1x is in front of the x. So this is really -1 divided by 4. I do not like to make the slope into a decimal. I prefer the slope be a fraction. So I'm just going to leave it as -1/4 x. And now that I'm in slope-intercept form, this number here is the y-intercept, that's the 2.5. And this number here, the -1/4, is the slope. All right, let's graph a couple lines. So we've now practiced putting the equation in slope-intercept form. Once the equation is in slope-intercept form, how quickly can you graph it? So the first thing we do is we recognize that this number is the y-intercept, and this number, the coefficient of x, is the slope. And we use those to graph the line. We start by putting a dot on our graph at the y-intercept, which is 1, so we go to 1 on the y-axis. And we take the slope, which is 2. Now 2 is not a fraction, so we might want to think of it as a fraction by putting it over 1. And the top number is telling me to go up 2, right? The top number says go up or down. Since it's positive, I'm going to go up. And the bottom number is telling me to go to right 1. So I'd start at the point I have already, the y-intercept, go up 2, go right 1, there's my next point. Up 2, right 1, there's my next point. Or I could switch both directions and go down 2, left 1, down 2, left 1, and I quickly have a line that goes all the way across my graph. Let's look at the next one. So the next one is already in slope-intercept form, right? The number out here is the y-intercept, -4. Let's go ahead and graph that point. Here's -4 on the y-axis. The slope of this line is -2/3. Now when the slope is negative, you want to, well, I generally assign the negative to the top number. You could put it on the bottom number, but what you don't want to do is put it on both numbers. Either it goes with the top number or it goes with the bottom number. I always put it on top. And the bottom number is 3. So this slope is telling me, well, the top number tells me up or down. Since it's negative, I'm going to go down 2. And the bottom number is telling me, again, it's positive on the bottom, so that's still going to be to the right 3. I need to go down 2, right 3. But look what happens on the graph when I try to do that. When I go down 2 and right 3, I actually go off the graph. So let's switch directions. Instead of going down and to the right, let's go up and to the left. Up to left 3, up to left 3, which also takes me off the graph. And my line looks something like that. All right? So the last thing then is, you've now learned how to take an equation and put it in slope-intercept form and graph the line. The last thing is, can you write the equation for a line? All right? I claim that you can actually now look at a line on a graph and immediately write the equation for the line. It only takes 2 pieces of information about a line to be able to write an equation for it. And those 2 pieces of information are, do you know the slope of the line, and do you know the y-intercept of the line? If you know those 2 things, you can write the equation for the line. It says here, you simply start with this formula. And if you know the slope, then you can substitute the slope in place of the m. And if you know the y-intercept, then you can substitute the y-intercept in place of the b, and you immediately have an equation for a line. Let's do some examples. So in example 1, you are given the slope and the y-intercept of a line. To write the equation for it, you just need to start with the formula, y equals mx plus b. You're going to take the slope and substitute it in for m. You're going to take the y-intercept and substitute it in for b. So the equation for this line would be y equals 2x minus 7. It's that quick and easy. Second example, if you had a slope of 2/3 and a y-intercept of 1/2, same thing. Start with your general formula, y equals mx plus b. Substitute 2/3 in for m and 1/2 in for b. And the equation for this line would be y equals 2/3 x plus 1/2. The next one, you were given a slope of 1 and a y-intercept of 2.5. You know, it's the same thing. I just want to point out a couple things here. If you put this in for m and this in for b, the equation for this line would be y equals 1x plus 2.5. But you know, generally we would not write 1x, would we? We would just write y equals x plus 2.5. And last up, what about when the slope is 0? Well, same thing. We would start with our formula, y equals mx plus b, and we would substitute 0 in for the slope and 3 in for the y-intercept, the b. So that would give me y equals 0x plus b. But we would never really write 0x, right? Because 0 times x is just 0. And I should actually substitute 3 in for b probably. So 0 times x actually cancels out the x, and a better way to write this would just be y equals 3. All right, our last example is actually the graph of a line. Can we look at the graph of a line and write the equation for it? Well, if we're going to do that, we need to know 2 things. We need to know what's the slope of the line and what's the y-intercept. So to find the slope, I would pick 2 points that are on the line, and I would make my triangle. The slope is up 1 over 4, so the slope would be 1/4, right? And the y-intercept is right here where it crosses the y-axis. That's at 2. Therefore, the equation for this line would be y equals 1/4 x plus 2. You can now look at a line on a graph and immediately write the equation for it. Hope that helps. Good luck.